for the change of not for the change of temperature. Such a heat is called latent heat. Latent heat will not show any change of temperature, in any rise of temperature. And latent heat will come into play when there is a change of state, physical state, from one form to the another form. Maybe liquid is changing into gas, or solid is changing into liquid. Melting time, boiling time, this will happen, or condensation time, or freezing time, that will happen. Latent heat. Okay. Write down definition of a specific latent heat now. A specific latent heat. Latent heat I gave last time. Now today, a specific latent heat. A specific latent heat denoted by L, capital L. Denoted by capital L. Symbol is capital L. Right? You know the word specific coming. What is the meaning of a specific? Unit mass. Now we take unit mass of a substance. Write down. It is the quantity of heat. It is the quantity of heat required. It is the quantity of heat required to change. It is the quantity of heat required to change the unit mass of a substance. Unit mass of a substance from one physical state to the other. From one physical state to the other. At a fixed temperature. At a fixed means constant. At a fixed temperature. At a fixed temperature. Stop. Now write down its SI unit is only joule per kg. J kg minus 1, or you can give a slash. Joule slash kg. Joule kg minus joule per kg. Now there are two types of latent heat. Normally latent heat of fusion and latent heat of vaporization. Okay, just write down definition. A specific latent heat of fusion of ice. Give the heading. A specific latent heat. Fusion of ice. A specific latent heat of fusion of ice. Under bracket denoted by the symbol like L with the F highlighted. Latent heat of fusion, F. A specific latent heat of F means fusion. Write down definition. It is the quantity of heat required. It is the quantity of heat required to convert a unit mass of the ice to change into water at a fixed temperature right under bracket 0 degree Celsius. At a fixed temperature under bracket 0 degree Celsius. Okay. Write down LF of ice, latent heat of fusion of ice. This value we are supposed to know also is 36 joule per gram or 336,000 joule per kg. Kg wise this much. 336,000. Just right now, next heading below. A specific latent heat of vaporization of steam. A specific latent heat of vaporization of steam. Under bracket write LV. LV equal to, write down this, just the value you write down. The value is this per gram, 2260 joule per gram, or in kg, 2260, 1000 joule kg. Changing in kg. 22,60,000. Okay. Put an asterisk and write down. When heat is supplied to a body, comma, the heat in energy increases. The heat energy increases both kinetic and potential energy. Both kinetic and potential energy. Both kinetic and potential energy. Kinetic and potential energy of the molecules. Of the molecules of the substance. Of the molecules of the substance. The increase in average kinetic energy of molecules, the increase in average kinetic energy of molecules, the increase in average kinetic energy of molecules is responsible for the rise of temperature. Responsible for the rise of temperature. Whereas increase in potential energy is responsible for thermal expansion and change of state. Right? During change of state, the average kinetic energy of molecules remain constant. Average kinetic energy of molecules remain constant, and so as the temperature. Therefore, just like therefore, the amount of heat supplied is the potential energy of the molecules. P can I get only increases potential energy of the molecules which is solely SOLELY, solely responsible for change of state. Understood what you have written? I'll tell you, listen, when we supply heat energy to a substance, now what happens? The heat energy will increase both kinetic energy of the molecules and the potential energy. Distance also will increase. The increase in the average kinetic energy of the molecules is responsible for rise of temperature. Agitation, thermal agitation is called temperature. Thermal agitation. More the thermal agitation, more the temperature rise. So which energy of molecule is responsible for the rise of temperature? The answer you will say in short only. They will not ask the entire details to write. Which energy is responsible? We say kinetic energy or average kinetic energy is responsible for the rise of temperature, increase in that value. So normally when we heat a substance, now what happens? Kinetic and potential both increases. And the increase in the potential energy will increase the intermolecular distances. That means expansion will take place. And same time the temperature will rise because kinetic energy is also changing, increasing. But when the change of state takes place, that time kinetic energy becomes maximum, saturation, means it is maximum now. It reaches the maximum value. There is no further rise of temperature and there is no further increase in the kinetic energy value, average kinetic energy value. The kinetic energy remains constant, whereas only potential energy increases. And that is responsible for the change of state. In short, what is the energy conversion during the change of state? You say heat to potential energy of molecules. Heat energy will change only into potential energy because the amount of heat supplied will not change its kinetic energy. Kinetic energy will remain the same. Only potential energy changes, which is responsible for the change of state. Which energy is responsible for the change of state? We say only the potential energy. Which energy is responsible for the rise of temperature? Kinetic energy. So that is the summary of this. Okay, what you have written. Okay, now specific latent heat definition understood. No, it is by nature seen that 1 gram of ice requires 336 joule of heat to melt into water at 0 degree to change its state. And for the steam, what is the value? 2260 joule per gram. Gram wise I am giving. 1 gram of steam, 1 gram of water requires 2260 joule of heat to change into steam at 100 degrees Celsius at the fixed temperature. The temperature will remain fixed because potential is only changing. When it changes sufficiently, then only the change of state takes place. Understood? Huh? Latent, if I consider this one, listen. When I consider this one, a specific latent heat and a specific heat capacity, which of them has got a higher value? Latent heat always has a bigger value, much bigger value. You can see the value. How much is the value? 336 joule per gram. Whereas SHCA water is the highest. And what is the value? Only 4.2 joule per gram per degree Celsius. That is just to change the temperature of water through 1 degree Celsius, we have to supply 4.2 joule of heat. That is the maximum value among all. But to change 1 gram of water into ice or to ice into water, how much heat is required? Latent heat is that time needed. No, latent heat value is unusually very high. What is the value? 336 joule of heat. There 4.2 and there 336. Just compare. That's why the change of state than the rise of temperature. Understood? Latent heat value is always higher. And if we compare the latent heat of fusion and latent heat of vaporization further, you will find that the latent heat of vaporization is much bigger. No, this is 336, this is 2260 joule per gram. This is 7 times higher. 3 7 are 21, nearly 7 times I say. It's higher than this one. Understood? Okay. Now, just below this, give the heading: heating curve. Heating curve. Heating curve. CURVE. Heating curve. What is heating curve? It's a kind of graph. Okay. We show the effect of heating a body continuously. When we continuously keep on heating, now what will happen? Now we'll see that. Mainly we do it for ice. You can write here like this. For example, you write here. For example, conversion of ice at minus 10 degrees Celsius to steam at 100 degrees Celsius. Your question even may come like this: a certain amount of ice is heated continuously till it changes into steam at 100 degrees Celsius. Draw heating curve to show this. For that, what we'll do, we'll draw two lines, not on the graph paper. Don't ask for graph paper in exam time. Roughly, sketch only will do sketching. Here I will take temperature. Temperature degree Celsius, this axis. That is y-axis, and y-axis I will take time. Either you can take time or heat. Time, either or heat. Amount of heat. Time or amount of heat. If you're taking time, you can give the unit seconds, minutes, and all. No need to give any unit right now. It depends. If you're taking heat, it will be, you can take in terms of joule. SI unit is joule. Here we show the different temperature at 0. 100 degrees Celsius, we have to show positive side, and negative side, we have to show -10. If I take a gap of 10, 10, 10, 10, so it will become too long, too lengthy, too high. So I will be taking a gap of 20, 20, 40, 60, 80, 100. Till 100 I am showing. Equal gaps. Degree Celsius also you read here, 60 degrees Celsius, 40 degrees Celsius, all the same units here. These are also I write a -20 below. Somewhere in between, -10 is coming somewhere in between. Show -10 also here in between. No? Time value, you may not show anything on here, just ice is at -10 degrees Celsius. We know there are two stages of change of state going to come. One is melting. First, ice will melt when you heat it. It melts at 0 degree, and then it will boil into steam. Then it will change into water, and water will boil into the steam. So there are two change of states. So first, -10 degree, I'll bring ice at 0 degrees Celsius. Yeah. Bring ice to 0 degrees Celsius so that it starts melting here. It starts melting. Change of state will show by a line like this way, parallel to the y-axis. This way will show. Because here, this part and this part will be longer. We know the quantity of heat involved during or it will consume more quantity of heat. It will take long. Melting starts from here, from this point, and the temperature remains same until the entire state changes. Here we are having the full change taking place. Let me say, changing into water, melted into water. Then from here on, temperature again will rise. From 0 degrees Celsius, you have to bring it 100 degrees Celsius, like this, 100. Yes. Yes. And then again another change of state will take place. That is the vaporization, boiling or vaporization. Again we show parallel to this line. Region of boiling or vaporization. Here like this, boiling. This line will show even bigger than this. Why? Because latent heat of LV is much bigger than 7 times bigger than this. No? Fusion and value is 336 and vaporization value is 2260. So much bigger. That's why that line will show longer than this one. Because temperature values, that is change of state. And here the temperature is changing, there is no change of state. So we can mark what is A, B, C, E. He will have the steam form. Process of here and it's complete over here. This is what region is this? This boiling. And this will draw ourselves. Sketching will do like this.